minus. It's called a hyperboloid of one sheet. This looks like the sphere, but it's got minuses in there. How many minuses?
2.
This is called a hyperboloid of
2 sheets.
2 sheets. Alright, we need some words to help us remember what these look like. Everyone, have you ever seen the cooling towers at a nuclear power plant? Your textbook author, I have to show you this. That's exactly what he used, if you can see it from here. Want to see those cooling towers, like at 3 Mile Island up in PA? Does anyone see the cooling towers? That's exactly what he put. He put that picture right in this section. That's what a hyperboloid of one sheet is. So I want you to think nuclear power plant. Look at those cooling towers. Now, when I make this cooling tower, it's pretty cool. Because it's going to bend like the hyperbola. It's going to bend in and bend out. Y-axis, Z-axis. Whoops, X-axis, Z-axis. What we're concerned about is, where's it centered? Now, which one had the minus as the coefficient? That's where it's going to be centered. Wherever that 1 minus is at the coefficient to the variable, that's the axis where it's going to be centered. So all I'm going to do is build my little cooling tower, bend in, and then I'll bend out. And it just keeps opening up forever, and it would open and open forever and ever and ever. That'll work. By the way, if you're curious, like how far close does it get to a 1 point? Now everyone, in the xy plane, this would have a radius of 1. I could prove it to you. Because in the xy plane, z would equal 0. And do you see it? There's like a circle, radius 1, right around there when it hits the xy plane. So it bends in, it gets really close, but it'd have a radius of 1 there.
That would be the narrowest it gets.
That's the narrowest this gets. And how about this guy? How many minuses?
2.
2 sheets. But which letter didn't have the minus?
X.
This is where it's going to be centered. See, here it was centered on the minus. It's going to be centered where there is no minus. And this looks like 2 little, almost like paraboloids, or little like satellite dishes. And there's a satellite dish right here. Everyone can see that. There's a satellite dish. Except this will form 2 along the x-axis. So what I'm going to do is I want to go distance. It'll be 1 away from the origin. I'm just going to open up a little satellite dish like this. Just go like that. It's like a little paraboloid. And then I'll go on the other side to make the other one. That's what they mean by 2 sheets. And it would just keep opening everyone. I did have to extend this x-axis to get my other one. This would be exactly 1 unit away. Okay? 1 unit away from that origin. And this would open up this way, and this would open up that way. If you're like, I don't like your picture so much, where can you see some really good pictures? See them then? Or you can draw them in WinPlot if you want. Hey, there's one last one that I never, ever make you draw, because I hate drawing them too. I think it's the hardest one to draw. Look in the lower left corner of this sheet. What's it called? It's like a saddle, everyone. It looks like a saddle. What is that thing? A hyperbolic.
Paraboloid.
I'll just put hype and then put paraboloid. I don't ever make you sketch this, but it looks like the paraboloid before, except what was between these 2 variables? Not a plus, a what? A minus. So that's the one you can just say, oh good. I don't know, he's never going to make me sketch that thing. A lot of times I like you to do matching anyway. That sound cool? Hey, I wanted to leave some time for the end. Everyone, you have a great weekend. Problem sets do what? Yeah, do Tuesday. If you got questions, let me know. Stick around. Hope you all have a great weekend. Super job.